Hello, this is the third video in the CPA series for OCR Discrete Further Maths. In this session, we will look at how to analyse an activity network. In session CPA 1.1, we noted that the question generally is, given the conditions, what is the shortest possible time a project can be completed in? This goes along with the phrase, time is money. Also, we made the assumption that tasks can be carried out simultaneously whenever conditions allow it. The analysis of an activity network involves finding something called the minimum project completion time, which is the duration of the longest path through the network. Any delay on this path will lengthen the whole project completion time, so this then is the critical path. The activities on this path are critical activities. To find the critical path, you need to work through the network twice, forward, finding the earliest event times, and then backward to find latest event times. To complete the forward pass, the first step is to draw a double box next to each node. In the forward pass, the number inserted in the left-hand box is the earliest time at which the activity starting at each node can begin. So we say that the project will start at time 0. So the left-hand box for the first node will always have a 0. You can then see that activity A takes 6 units of time, and so therefore the node 2, which shows that A is completed but also B completed, will have at least a 6 in there. Let's consider node 3. B's completion will take at least 4 units of time. The dummy, although it doesn't have additional weight, means that we have to, before we fill in the left-hand box at node 2, consider whether 4 or 6 is the greater. In this case 6, so we would place a 6 in that left-hand box. Node 4, then, the left-hand box for that, D is going to take 10 and A has already taken 6, so that will have a 16 in it. That's the earliest time in which D can be completed. For node 5, we have 4 plus 13 gives 17 as the earliest time that E can be completed. Again, I would have looked to check which was the bigger number, the 16 or the 17, because of this dummy here. So node 5 represents both E and D being completed, and the earliest time that this is possible is 17. With the box for node 6, I need to consider that C will take 15, but that D completed followed by F completed would take 20, and G completed would take 19, so I choose the biggest number, in which case 20 goes in there. Remember, it's important to realise that the event cannot start until all activities leading to the event node have been finished. The forward pass now completed, we can see that the minimum completion time for this project is 20 units of whatever time we're talking about in the context of a question, whether that is minutes, hours, days, months, or so on. It cannot be completed in less time than this unless something changes. We would now start the backward pass, because it is also useful to find the latest event time at which activities might finish if a project is to be completed in the minimum completion time. We would start by using the same number in the right-hand box for the sync node or the completion node, and then working our way back through. With the forward pass, we chose the largest values. On the backward pass, we will choose the smallest values. In this case, 20 take away 2 would give us 18, as the latest time that G can start in order to be completed by the time 20. Looking back then to node 4, for F to be finished by 20, the latest time it can start is 16. You'll note that sometimes we have the same numbers in the left hand and right hand side boxes, but they don't necessarily need to be the same. Working back from 16, for D to be finished by 16, the latest time it can start is 6. For E to time it can start is time 5. And working back again, for A to be finished by time 6, the latest time it can start is 0. So you always have the same numbers placed at the sync node in the left and right hand boxes, and you would expect to always have the left and right hand boxes being 0 at the source nodes. That's just a way of helping you check your work. So the latest event time is the latest time that an event can occur without delaying the whole project and increasing the overall project completion time. Now that you've completed both passes, the earliest start time and the latest finish time for every activity can be read off the network. So for example, the earliest time that E could start would be time 4, and the latest time it could start would be time 5. In session 1.4, we will look at finding critical activities and critical paths.